Good day, guys. How are you doing today? Today we continue our lecture series from where we stopped. Today we are going to look at recursions in C programming. So now let's see some outline. Let's see, we're going to look at the introduction of recursions, the organizing larger programs using headers and separate compilations, also C preprocessor directives as well. But before we go into this, let's look at some questions and let's address some questions to be able to on what we have taught before. So let's look at these questions and let's see how we can solve them together. So let's try to see all these questions. Let's begin from question 1. Let's open our Visual Studio Code. Then I've created a folder here. Just this C here. The question says that write a C program that prompts the user to enter a year and determines whether it is a leap year or not, based on the Georgian calendar rules. Display an appropriate message indicating the results. Let's look at this. Also, let's look at true or wait. I can also explain the third one. So we can just explain it, and so I can just look at the first and the third one. It probably to reduce our time. Then let's see that let's open our Visual Studio Code now. What are those things? Let's click the question 1 first. A C program to program the user to enter a year. A year, what are the things to look at before we start coding? Then how do we determine a year? You can pick the year 2024, 2025, 2026, 2026, 2027. You can pick what year 2000, year 1900. Let's determine how this year can be a leap year. You have 365 days in a year, but if it's a leap year, there's an increase in maybe 366 days. Understand? And it is affected by February, right? So February, right? So now let's solve the try to address the problems. And this is how we're going to look at it. I think I put some questions. How is it being determined? If we can express our problem mathematically, so then we are halfway done. Then let's look at it. I'll put some instruction here. This is instruction. If the year is evenly divided by 4, it is generally a leap year. So it can be divided by 4. 2025 is not a leap year. But if divided by 4, it's generally it's a leap year. But however, it has to be divided by not by 100, but by also 400. That's considered to be a leap year. Understand? So let's look at it. If the year is evenly divided by 4, it's generally a leap year. However, if the year is evenly divisible by 100, it is not a leap year, unless it is the year. If the year is also evenly divided by 400, that makes it a leap year. Now let's look at some instances here. Divide 2024. Is divisible by 4. Yes, divisible by 4, then and not divisible by 100. So it was not a leap year. 1900 is divisible by 4. It is divisible by 100, not divisible by 400 as well. So this is not a leap year. It's divisible by 100, but not by 400. And also, 1900 was not a leap year. If you pick a calculator, let's pick a calculator here. 1900 divided by 400. So we have 47.5. But let's look at 2000. Let's look at 2000. 400 year 2000 divided by 400. We have 5. So it's a leap year, and it's also divisible by 4. We have 500, right? Then let's write a program to address this issue now. From here, let's include our the standard library std. So stdio.h for our print input outputs. Then we have then let's create a function. We're going to be acting based on what we have done before. We talked about function before. We talked about loop. we talk about switch statements, we talk about control structures. Now let's use those things in function. Let's modularize our problems using the C code, using the information we have here now. Let's create a function. We can make it, okay, if it returns 0, that means you can make it, if it is 0, if your result is 0, that means it's not what? We're also going to use the ST library, maybe Boolean, true or false later. I'm going to demonstrate to you. Now, if it is 0, maybe int, it's leap year. It's leap year. Is a year is always in positive, not an integer. Unsigned int year. Then, if year is modulus of what? If the year is evenly, we can also, okay, if modulus of 4 equal to what? 0, and we accept that one generally, divided by 4, that is what? If year modulus 4 is divided by 0, and but it's not divisible by it's not divisible by 100. Yes, 100. And sorry, the logical operator, and year modulus 100 is not equal to what? Is not equal to 0. Then this tackle the 4 instances. You can also separate it. I will show you also where I've separated it. Maybe where I will show you as well. Sorry. You can also put it inside a parenthesis this way, or the year also is divisible what? Year modulus 400 equals to what? 0. That means it's what? It's a leap year, right? It should return 1, for example. Return 1. Then S, and you can also return 0. So you can also put S here, but this is just number code here. Now we have a int main, our main function to check whether the year, but remember, we ask the user to enter it. The question says that we should enter it from the user. So where is the program that comes the user? So the program needs to tell the user to enter a program. So let's int number. Then let's print f. Please enter a year. Then use scanf to get use scanf to get the input in C to D. Then get the address of the number, the address. So we're going to talk about everything. Yeah, pointer later. Then we have got it. Now this, by doing this, we're going to get what the user enter. Let me the number. Let me just display the number for us here. Let me tell you what we enter now before I jump. We continue, so we can have it here. Yeah. Okay, CD, just CD P6. Oh, so then we now have a G++. If we Q1 output, sorry, O, Q1, this is O and not 0. Q1, we are giving it a name, we are compiling to a name. Yeah, we are giving any name, it can be any name here. Q1 and Q1 comes what? Q1.c. Let's compile this now. We have no error here. The Q1. Then we have what? Enter here. 2025. For example. So you have 2025. So our input is working. Then let's determine whether it's a leap year or not a leap year. So then we can easily use this function we call there. Remember, it's taking in what? An unsigned input number, unsigned int. So therefore, let's check if number, if the function is leap year of number equal to what? 1, then because we are returning 1 here. If it's true, you can also make it true or false. If it's 1, then print year this is a leap year. We have a new line there, then we have a number. Then S is S with F, the year this is not a leap year. Let's try to run it, Remember, we are returning to 0, this default one, our intimate, our entrance of the program. Then we compile again. Then we will enter the year. We have 1900. Year is not a leap year. And remember here, 1900 say what? It's not a leap year, right? And the year, but let's try with 2000. It's a leap year. It's a leap year, right? It's a leap year. Then see that means our code is working correctly. We can also determine to use maybe as a leap, as I said the other time, include std leap, std bool.h for Boolean operations. And also just copy the same code. You can just change it to be what? Bool. So it's taking return true, return false. So you can do the same thing and just, okay, if this one is going to be true, if this, then we will need to do the anyway, just if this, else this. Let's compile again. We'll compile our code. Remember, I don't need to save it. It's already saved. If you check my VS Code, I have auto save here. So you have to be aware of that. Then I can compile it again. Sorry, I can compile it. It says, if it's in, it says what? New declaration of boot is leap year is int. So it says not all declaration. Int is a leap year. So I'm seeing something. Okay, sorry, I'm having name confusion here. Let me just rename them as and just name this one as number to hide something. It's going on. So we have name conflict there. So it's not work like a much function overloading in C++ or Java. So, but now it's working now. Let's try to compile. Let's compile it. Let's enter a number. 0 is not a leap year. They're also working for Boolean and also the same thing for number. Let's also try for numbers as well. 2016. That's 2016. It's a leap year. 16 divided by what? 400 also divided by 4. So now let's look at the second question. Let me just put it through. You can just modify this code for the second question, but I'm going to address it now. So you write a C program that prompts the user to enter a month number 1 to 12. Based on the input, display the number of days in the corresponding month. For February, indicate that it has 28 or 29. Remember, this will only happen when it is a leap year. You can just do that by just easily creating I'm not going to finish the code for you. Just have to do it yourself. I just include std sdio.h, then the former something here. You can just complete it here. Just come to the former code here. Most of the time I have to be copying. Just come here, just put it here, or you can just include it straight. Include sdio std bool, so that all this will disappear. Then we have this, its main. Don't forget. Then we have to use the statement. Then we also copy almost done. So you just finish. Just enter a number. So just enter 8. Why is this? So return 0. So then you can just use the switch statement here. The switch case to have number, right? Number, that's in month. But this one is asking us in months. Please enter a month, right? Please enter a month, right? So you can put, if the month, you can also put a check to return. If the year, if the month is greater than, okay, we're going to put it also in the default section. So if the case, maybe case constant month, the first month, which is January, yeah, month one, which is January. Then we can also have our code here. Okay, okay, this is January is what? 30 is January is what? How many days? It's 31 days. But mind you, February, if it's a leap year, it's going to what? It's going to be 28 or 29. Then case 2, which is February. Then also still just break it here. In semicolon. So then if the question tells us that if it's for January 28 days, then we can also check for booleans. Then you can say okay, if month is equal to 2, that means if the year, let me just see the question again. It's program that prompts the user to enter a month number, right? Based on the input, right? Display the number of the days in the corresponding month. Or further indicate that it can have 28 days. But if, you can also say, okay, if it's leap year, then if it's leap year, then you can also have a year. So I just find a year here, for example, unsigned int year, maybe 2030. So for example, you can just put your year here. So if the year is this, then if it's leap year, you get that. If it's leap year, that means January is 28 and February is 29 days. And you have to break S. Just break it. Can just put here February. Let me just put S so that you won't be displayed, you won't be confused. S February, just point F. February is 28. February is 28 days. Just rushing. So we have this now. That means that tackles that. Else the default one is what? Invalid month supply. You can just say again. Invalid month supplied. Remember, September is 38 days. Whether it is leap year or not leap year, there's another month like that. So April, also April, May. So there are some months that also are 28 days. So you can complete the remaining code for it to work. You get my point? Now let's look at the last code here. I've told you already I'm not going to complete the code. Just you also need to dirty your hand, but I've done one of the important work you need to know about it. If you also still have issue about it, please let me know at the comment section. And now let's look at the third questions properly. Let's look at the third question, that is Q3.C. The third question says, the third question states that write a C program that prompts the user to enter a positive integer n and then display the first n terms of the harmonic series along with the total sum of the series. The harmonic, you have to determine this series. We have to print all these series. We are given the question to print what all the series the way it look like, and also also display the sum of that series. Now let's look at it. What are the things we need to look at here? We have to enter an n. Maybe we enter 10. So we're going to stop at 10 here. The harmonic series will enter 5. It's going to stop at 5. Our n will be 5. So we are going to start from 1 to 5. Let's take it gradually, step by step. Let's take it for a step by step. What's my VS Code? So now we have include stdio.h. We have stdio.h. Then we have what is it called? Okay, no, sorry. Then we look at the rough figure. We look at this question. Let's display the series of the numbers. Let's firstly print out all the series. Let's move from 1 over 10. Remember, the series is in what? 1 plus 1 over 2 plus 1 over 3. Let's ask the user to enter a positive integer n. Let's first solve this question first. Let's break it down step by step. Let's first solve these things. Let's get it right. From our first code that tells us that we need to enter an integer n, right? So we use the functions, or I just put inside main series. Can make our code quickly. Let's put this in separate functions. Let's just make your photo prototypes. Let's just create, okay, maybe just create something void harmonic series. So just enter, maybe just the user to enter a value of n, int n. It says a positive integer, that means it's of sign int n. So this is function declarations. And the function declaration or prototype. Then we can now implement the function down here. Before then, let me return this. Then we now have the function prototype here. Then let's now implement the functions harmonic. That is what? Void harmonic series. That was unsigned int n. So if we don't put this, so I'm going to be having an error, the function not declared. So therefore, by still coming back to the main function here, then let's try to display the first question. Says write a C program that prompts the user to enter a positive integer n. So the positive integer n, let's int number, for example. So it's going to be unsigned int number positive, which is yours. We'll just give 0 first. Then print display message. Please enter a positive integer. You can also tell the user, in case the user will go ahead and enter the wrong thing, You can just write a function to check if number is less than 0, then always tell the user this scan f, the address of the number, then always keep on tell the user until the user enters the correct values. So once we have it, we get the value here. So we have it here. So just say here, error. Please enter a positive integer here now. So let's firstly try this one now. And let's firstly see what we're going to do here. What's going on the G++, that is Q, theory. It can be anything. Let's just name it anything. PSN, that's your POS. And then just give it, let's give the name. It's output or output, then PO. Let's just call it PP. Or it can be anything, just name it anything. Then we have Q3.C. Then we have, then if we want it to PP, please enter a positive integer n. If we enter 34, can you see? We are good to go here. But let me just put something so that we can have now enter a positive integer. Enter what? Minus 45. I see. It says, please enter a positive. I'm coming. Do I compile it? Minus 45. Or it's still telling me this. Please enter a positive integer. Want to know the reason why it's not entering here. If number, y number is less than 0, you should do this. What is it? Minus 1. It's enter a positive. It's not entering the loop here. I went back. Let's just fine tune what the problem is. Welcome back, please. I discovered the problem that is because we put our unsigned here. We already checked it here. If we put unsigned to integer number here, and I try to add this number, I remove this number, I check the unsigned. Unsigned will not enable us to take in any negative numbers. So that is what, once we have unsigned here, for example, you will see that it's going to turn into positive for us. So that means we are going to always have positive numbers all the time. Now if we compile it back again, now if I enter minus 90, and you see it's changing back to 90. So it's not taking in minus 90, but it's taking in what? A positive 90. So let's just remove this. So since you have a custom check to track our what any negative number, now remove this, and we now recompile the program back. So we see that the program is going to work. Maybe minus 89. Can you see error? Minus 78. Can you see? Minus 35. But when I enter 87. Can you see? So now we are good to go with this now. Then let's try to implement the series, the harmonic series. Then the first number there is what the n. Let's remove this. To add our what? Okay, I'm sorry, let me do it for me. So it's already declaring error. So now we have a n now. So our number will be starting from the initial number, which is 1, plus the sequence number of it. Remember, in the program, the sequence goes this way. The first number will be added to be what? To the other port or to the other, to the one over the other numbers. Understand? Now let's look at this. For example, if we enter like maybe 5, 10 now, or maybe 5. So we're going to have like 1 over 1 plus 1 over 1 over 2 plus 1 over 3, because 1 over 1 is still 1. It's not the same thing, just leave it that way. But 1 over 1 is still 1. So let's just try and let's just add it. Let's look at what? 4 int I, we're starting from 1, I less than equal to what? N I plus plus. Then we have this one. Now, we want to make the series work. Print F. Well, go to print. How are we going to do that? Well, remember, also going to have sum. The sum of it, the sum of all the sequence as well, is also required in our code. Let's declare in sum here. In sum equals 0. So then print F. Then we have our series in this form. Remember, it's a number. Remember, if just 1 over 1, since 1, just 1, for example, just 1 all over, that'll be 1 over 2 over 3 over 4. And our I here is representing the number. This I here is representing the sequence of those numbers till you get the final number. Then we have our percent, let's just represent what? Percent D. Percent D. Sorry. Yes, that would be 1 all over percent D plus. Yes. I'm not putting slash new into new line here, but let me now check something here. Let me check that. Okay, if for us to include this addition of something here, there's something we're going to do, but just let me allow you to do that. Let me allow you to see that. Let's do it for the other one as well. The sequence is this one. Let's also do for the other one. That is our sum equal to what? Plus equal to what? I, which is our I, for example, our I. Do you remember what it is here? It means that sum equal to sum plus I. It's what it means here. Then we are good to go here. We return only the sum. Then let's make this what? 8 then. And let's change this one back to what? 8. I say I want to print out all the results there. So let's just check this. Let's check the code now. Let's check this code. So let's check this code now. Then we have harmonic series. Harmonic series. Let's display our result here. Print F. Can you still declare series in series? Let's call it series. What's called harmonic series to make it clean into bits. It's taking into what of number. Then we can now print what? Print then we now have print F sum of the above series. Let me just print here a new line to avoid being joined together. So we have it this way: above series of the above series is, I said, but it's not just, this is just displaying the numbers now. That will be what? I That will be I divided. Must be what this one could be what I divided by, that will be 1 divided by I. That is the sum of the above series now. We're going to sum them together or we'll get the results. Then sum is D. It is good for us to get that information right so that we know what we're doing. So then we now have what the series. So then we're resisting given. Now let's try compiling it. We have issue. Okay, I've now returned. We have to return sum here. I have to return the sum. Then we have enter integer number. Maybe for example, we have what? We have 5, for example. It says 1/5. But we have an issue with our code plus one over this. So this is my breaking on issue or something. All right. So okay. Okay. Now let's continue. I think this is why from 5. This is why we're having this because we fail to pass the value here. Since we have placed the placeholder here, once I place it here now, the high, which is our high, it should be fine, right? Then we have it here. Then compile it here. Then we have 5. Then we have 5 here. We have some issue here. We have now we get it rightly. We also have plus here. We can come back to this place and check. If you have not gotten to the end, then you should not include this. Then let's remove this from here. Instead of us removing from that place, let's just give it space. So let's just leave it this one. And I just print another statement here. Maybe if, just move it that way. If I is less than n, then we should add print f. Remember that space plus space. So remember we're not adding /n so that everything will still be on the same straight line. It will be printed together. Then let's try and see it again. 5. Okay, fine. 1/1, 1/2. All right. Then we are good to go here. Then it should mean our sum is 1. Why? Because all this will be a decimal point. So we have to change this one back to double, and double. Let's try to sum it now. For example, then this one will be 1.0. We should let's just try and solve it now. Let's just rerun the program. Can you see? It said the above series is 2. Okay, let's make it run it and make it. Imagine you're having 2. You still have issue with it. Our sum also is double, but we are returning double instead of what? See what is happening here. Double. So that means we're expecting double here, not 8. So let's get the answer right now. We compile what's going on. Double harmonic series. Okay, here. Nothing. So apology, guys. So let's compile it again. Yes, 5. I see. Then the series is this. The reason why again is we are using this percent D. And D is for integer. We use float for F for floats. LF is used for long floats in case of any issue. So floating point variable numbers. So we have this. Fine. We have 2.283. So we get this F element long floating point number. So floating point number. We get the result now. We were able to print out any series. You can also print out to, let's get like 20 series of n. You can just okay 20 series of it. And see, you get it. And in some series of that of those series is 3.597 or something. Okay, all right, guys. Please, I'll be stopping this video. So for the next lecture, we start our recursion. Please, the video will be too long. All right. Thank you very much. Please like, subscribe. Bye bye.